That is what I wanted. There. Why would I need a module? I don't understand. Must be something I'm missing here. Oh, it says... So basically, this is supposed to be done during December, but I'm lazy and didn't do it, so I'm doing it now. You need to get all 50 stars by December 25th. I got time. Easy. Find two entries that sum to 2020 and multiply those two numbers together. Okay. Simple enough. Here's the input. Gosh. Where did Eclipse put this? Here. I assume it's gonna go in here, but do that for now. Yeah, they give you puzzles and you have to solve them. And they're looking for an answer, so. I will start by making a main class. I'll just call it AOC1. Oh god. Why is this window retarded? What is this? Welcome. Don't show this ever again, please. Oh god. This is a new computer and I haven't configured anything, so this is gonna be annoying. Let me... Can I... Hello? Can I like zoom? There we go. That works. So let's first see what directory we're in, I guess, because I have no idea where we are right now. We need a new... That should tell us where we are. Run. We are in, okay, that looks good. So we just have to read input. Input straight. Why am I doing this? I'm just gonna import my library. Why? Why reinvent the sig wheel when the sig wheel already exists? Oh, what's a image parser? Go there. Surely my... What? Here we go. Sig. Utils. This is what I need. I might as well grab this. Team. Import. Git. Yep. Come on. Any day now. Holy moly. I think this thing has images in it, that's why. Yep. Sure does. Great. This one says there is one pair of numbers. It says, find the two entries that sum to 2020 and multiply those two numbers together. Yep, so that's what we're doing. Alright, these are my utils. Cool. What? Oh, this probably has to be sig.utils. Yep, let's change that. Good. Now inside of file utils, I should have a read file. Read from file. Input.txt. We should get an array, I think. And for now, I can just do arrays deep to string data. Okay, good. That should read from the file. There's all the data. So now we just have to figure out what's what. So convert them all to numbers. Yeah, I should probably actually convert them all to numbers. Make an int array that is the same size. Numbers. New int data.length. We're going to do a numbers I will be equal to integer.parse int data I. Now we should have an array of numbers instead of strings. I can double check that. What is the key shortcut to run? There we go. Really? Alright, doesn't work on primitive types. That's fine. Kind of weird. And now I'm gonna go through all of them. For int I 0, I is less than numbers, length. For int j 0, so for each number, we have to look through all the other numbers. But don't look at the one we're looking at now. So if I is not equal to j, then we're gonna add them together and see if they're equal to 2020. And if they are, we're just gonna end the program here and output what these two numbers multiplied together are. We should find one. If we can't find one... Oh wait, this is void. Let's... Can't find one, we'll return an error code. Alright, cool. I probably... Oh, never mind, that's not how this works. Well, in that case, I'll just return. If we get down here, we couldn't find one, so I'm going to say could not find two numbers that added up to 2020. Alright, cool. So that should be our answer. That's the right answer. You are 1 gold star closer to saving your vacation. Part 2. So there are 2 parts to each day. The elves in accounting are thankful for your help. One of them even offers you a starfish coin. They offer you a second one if you can find 3 numbers in your report that meet the same criteria. Using the above example again, the 3 entries that sum to 2020. Oh. What is the product of the 3 entries that sum to 2020? Oh, so there's more than one. I just returned immediately after. So they want the sum... The product of the 3 entries... Wait, what? The 3 entries that sum to 2020. Oh, so we're looking for 3 numbers now. Great. Okay. Alright, so... Oh. Sorry, I'm not... I get into programming and then I don't read chat. Is there a faster solution to picking a number than adding it to another and see if sum is 2020 and looping it? Picking a number, then adding it to a number. I don't think so. You can do some sanity checks, like if like you know the number has to be at least a certain value, so you can just not even add them together if the number is below a certain threshold, and that would save you some time. But in terms of efficiency, I don't like, I'm pretty sure usually what happens, I've looked at the ones in the past. Usually what happens with these is they get harder and harder in terms of making efficient solutions. So they like challenge you to eventually make efficient solutions, otherwise your answers are going to take like hours to compute. So right now, that is like the least of our concern. I can't add another for loop because I have to track the 3 numbers I'm adding. Well, I guess what I could do is just check if all 3 numbers are not equal to each other. Yeah, I guess I could do that. That's fine. I was gonna like actually make an array storing how many, but I doubt we're gonna need to track more than 3 numbers. If we have to track like 4 or 5 or 6 numbers, I would probably make an array of numbers and say, make sure all these numbers are not equal to each other. If I is not equal to j and I is not equal to k and j is not equal to k, then they're all different values. Add them all up and see if they're 2020. And if they are, give me the product. Although, this is not the greatest way. This is not very flexible. It's just kind of a brute force. That is the answer it gave us, so that's the right answer. Yay, you have completed day 1. All right, only 23 more days to go, and we have 2.5 hours. That's not gonna happen, by the way. Well, this looks cool. I haven't looked at this since, like, day 3. What's going on? Alright, day 2. I'm gonna turn on my thing. That way I can hear if somebody chats, because usually that's why I do this. So I can actually hear. Alright. Go there. Cool. Yep. It says, your flight departs in a few days. The shopkeeper at the North Pole Togglebin Reptile shop is having a bad day. Something's wrong with our computers. We can't log in. Their password database is a little corrupted. Some of the passwords haven't been allowed. If it shows effect, try to the problem. They've created a list of passwords and the corporate policy when that password was set. Each line gives the password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. For example, 123A means the password must contain A at least 1 time and at most 3 times. In the above example, 2 passwords are valid. The middle password CDEFG is 9, contains no instances of B but needs at least 1. The first and third passwords are valid. They contain 1A or 9C, both within the limits of their respective policies. How many passwords are valid according to their policies? Alright, well, looks like we have to give a number by checking all these passwords. Cool. Alright. Looks like this is going to be a parsing problem, because they're not really formatted very well. I'm going to call this input 2. I really should put these in separate projects, so I'm just gonna... do I? I'm very tempted to just make another class, but I feel like that's... Alright, we're just gonna make a million projects. Here we go. Crud, I didn't want to make a module. Go away. Class AOC2. What was that boy made? Input. Alright, same deal. I'm gonna read in the input. Then we're gonna do stuff with it. I'm gonna have to import this again. Ew, that is not in a package. You need to be in a package. And there we go. Nah. They're too good for password managers, apparently. Alright, so... It doesn't look like passwords have spaces, so we can parse these by spaces. So that's what I'll do first. It's gonna be split into 3 pieces, and then we're gonna have to parse all the pieces. Okay, well. It's gonna be an array again. I'm just gonna call it pieces. Data I split by spaces. I don't actually know if that's valid regex. I guess we'll find out in a second here. I have a feeling it's not. Huh. How about we... It was valid regex. They put a space in front of these, though. That's kind of weird. I feel like that's probably because this isn't valid regex. Maybe 2 spaces. Maybe, whoa, nope. Maybe, let me think. Maybe a stringlet. Nope, that's not gonna work. Maybe a literal? Nope. Alright. Well, I'm just gonna go with it and then remove the space myself. So... First piece. Split into a range. Actually, yeah, split into a range. So we got a low and a high. Low, high. Low. Piece 1. We have to split it though by the dash. Hopefully that's valid. And use the first one from there. And the high should be the second piece. I'll put both of those, make sure those are correct. Low, high. It's looking good to me. Okay. Now I just want this letter. I'll just grab the second character. Character, letter is pieces 1, character at index 1. Should give us our letter. That's a colon. Oh, so the array's deep to string as the space. Okay, that makes more sense. I was wondering why there was a space. So that should be our letter. Good. And now we have our password. And we have to count the number of letters of the letter in that password. I is less than pieces 2 length. What? It's a string, that's right. I already used I, let's use like J or something. How do I refactor, please? Alt-Shift-R. J. So we're just gonna count all the letters that are equal to the letter. If pieces 2, character at, in position J is equal to letter. Is this gonna return the primitive type? It is. Well, that should work still, though. Then... Or will it? Hold on. I don't know. Actually, that's a good question. It probably will. I think Java's smart enough to just convert, because it's just... I'm just gonna make an assumption here that it does assume it's gonna be equivalent. So we're gonna count. We'll have a counter. Letter count. Letter count goes up. See if the number of letters is between the two numbers. Is it between or has to be at least one time and at most 3? Okay. Yeah. So it has to be in between or equal to those numbers. If letter count is greater than or equal to low, and letter count is less than or equal to high, then it's a good password. How many passwords are valid? So we're just going to have a variable called valid passwords. Starts at 0 and increases. Do that over and over. And then in the end, we'll output how many valid passwords there were. And we're done. There were 520 valid passwords, apparently. Hopefully that's right. That seems a little large. How many? Holy. There's 1,000. Okay. Yeah. Well, that seems like a reasonable answer then. That's the right answer. Part 2. While it appears you validated the passwords correctly, they don't seem to be what the official Togman authentication system is expecting. The shopkeeper suddenly realizes he just accidentally explained the password policy rules from his old job at the sled rental place down the street. Each policy actually describes 2 positions in the password where 1 means the first character, 2 means the second character, and so on. Be careful, Tungman have no concept of index 0. Exactly 1 of these positions must contain the given letter. Other occurrences of the letter are irrelevant for the purposes of policy enforcement. Given the same example list from above, 1 to 3A, ABCD is valid. Position 1 contains A and position 3 does not. CDFG is invalid. Near position 1 or position 3 contains B. Okay, is invalid. Both position 2 and position 9 contain C. How many passwords are valid according to the new interpretation of the policies? Okay. So only one of these 2 positions can have that letter. All right. And it's asking us how many passwords are valid according to this policy. Well, let's find out. I feel like I should just kind of like this one. I want to keep it. So copy paste this, but I don't want to get rid of the first part. It's kind of dumb. Okay. So instead of seeing this as a low and high as the validation, now we're going to see if okay, we don't need the loop anymore. We'll say if this is 2 character at low is equal to what was our letter XOR pieces 2 character at high is equal to letter, then we have a valid password. We have to use XOR, which means only one or the other can be true, not both. And what I do? Oh, there might not be a letter at that position. Well, right, because some passwords are invalid because they don't even have the right letter count. Well, if the number of letters is high enough, how about that? Otherwise, it's not going to be... Wait. Now wait. What happens if the password is shorter? Well, I guess it must be an invalid password in the first place, so maybe we still need this part. We need to determine if it's a valid password before we can consider checking if it's a valid password for this new policy. Alright, let's try that. Maybe that's what they want. Oh, I need to subtract 1, because position 1 is index 0. Minus 1. Wait. Huh? Letter count. Okay. Yeah, that makes sense. 283 are now considered valid. That's not the right answer. Your answer is too low. Maybe it doesn't have to be a valid password then. Okay, let's try this again then. Alright, so if there's not enough letters, and at least this is true. Oh, I still have to subtract one. Hold on, let me do that first. I don't think this will work because I'm pretty sure there are invalid passwords in here. Oh, 497. Does character at now return? If the index argument is negative or not less than the length of the string, you get an index out of bounds exception. Well, we didn't, so try it. Okay, that's the right answer. I'll take it. Hey, not complaining. All right. While the toboggan login problems resolved, you set off toward the airport. While travel by toboggan... Toboggan. Wait, how do you pronounce this? What is this word? Toboggan. 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 Alright, that's what it is now. It's the toboggan. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering in areas covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. Okay? You make a map of the open squares and trees you can see. These aren't the only trees, though. Due to something you read about once... What? Due to something you read about once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. You start on the open square in the top left corner and need to reach the bottom. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope. Right 3, down 1. What? Okay. From your starting position at the top left, check the position that is right 3 and down 1. Then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked here with O, where there was an open square, and X, where there was a tree. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting at the top left corner of the map, and following a slope of right 3 and down 1, how many trees would you encounter? Oh man, this is gonna be a big one. Alright, so there's 2 pieces to this. This like vertical slab of text needs to be copied many, many times horizontally. And secondly, we have to count the trees. Alright, input. Input. Alright, make another one. I really should just copy the project and then we don't have to do this every time. Refactor. Okay, yep. Get rid of this. Yep. All right. Well, I mean, we don't really have to make copies of this over and over to the right. It's just when we get to the edge, it just wraps to back to the beginning. So, I think I want to track an X and Y coordinate. And we'll use that to determine where we are on this thing. I need to read in all the data and be able to convert that to X and Y coordinates. I'm gonna make a function for this because this will make it easier to understand. Get coordinate x, y. We store this. I want to do it. I guess I'll just do this. We'll parse it from there. So, based on whatever we read in here, the x coordinate will always be the character at whatever position on the y coordinate of whatever line. So I will have to return a data. The y coordinate will be the y coordinate will be whichever line, and wait, this needs to be like a point or something. Return new point. Wait, no. No. We just return a character. Yeah. Return a little, whatever character is at that position. Character at x. And it needs to wrap, so we'll do a modulus data 0 length. Boom. There we go. That way it wraps around. And now, for example, if I want the character at, let's say, coordinate, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we'll say 15. Get coordinate 15, 0. We should return that hashtag mark. That's not static for whatever reason. Okay. And it gives us a hashtag. Let's try the one right next to it. The 16th position, which should be this dot. And now let's try the one right below it, which should be 16, 1. And let's try the wrapping by doing 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Let's try 34, which should be this hashtag. It is, and then let's do 35, one to the right of it, and that's a dot. It looks like it's working. So from here, we now have an easy way to count the number of trees. So we're doing right 3, down 1 each time until we get to the bottom of the slope. Can you explain the modulo stuff? So modulo is it divides the number and returns the remainder. So if you do 12 modulo 7, it's going to return 5 because it's going to be 12 divided by 7, which is 1 remainder 5. If you do 49, it's going to return 0 because it's going to be 7 remainder 0. That's what modulus is. So it's good for things that wrap around because it just returns the remainder. So when you have a lower number, like 5 modulus 7, it returns 5 because 5 divided by 7 is 0, remainder 5. Right 3, down 1. So while y is less than data.length, x goes up by 3, y goes up by 1. Check if it's a tree. Count the number of trees. Int tree count. If get coordinate xy is equal to tree count plus plus. output the number of trees. Y is less than data.length minus 1. Because we don't want to slide down the... Wait, 232, that doesn't seem right. Oh, maybe it is right, actually. Yeah, there's 323, okay. It just seems really high, but YOLO. That's the right answer, alright. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop, after all. Determine the number of trees you encounter if, for each of the following slopes, you start at the top left corner and traverse... Yeah. Right 1 down 1, right 3 down 1, right 5 down 1, right 7 down 1, right 1 down 2. In the above example, these slopes define 2, 7, 3, 4, and 2 trees. Multiplied together. Multiplied together. Okay. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Alright, so we just have to do more slopes now. I'm probably just going to write in the number of slopes and loop through them real quick. So I'm going to make a... I'm just going to use a point structure because they accept 2 values. Slopes. New point array. New point. So one slope is right 1, down 1. Next slope is right 3, down 1. Then we have right 5, down 1. I'm a little concerned about the down 2 because I did not factor that part in, so I'm going to have to do that. Right 7, down 1, and right 1, down 2. And now, I'm going to say 4 into I is 0, I is less than slopes length, I plus plus. Okay. So we have to get the tree counts of each one, so I'm going to store them in an integer array, tree counts. Actually, multiplication is associative, so the order of multiplying doesn't matter. So I am going to store a tree count, but in here, then we're going to have a multiplied tree count up here, which should start at 1, not 0. Probably. Okay. Y is less than data.length minus the slopes y, because we don't want to go past that. X plus equals slopes I dot x, slopes I dot y. And that makes trees. Okay. And then when that's all done, we need to multiply everything together. So multiply tree count is multiplied by tree count. And then output multiplied tree count. 0. That means one of these tree counts was 0, which is not correct. I don't think. Let's see. I.y. I have to reset X and Y. That's what I need to do. That is not right either. That is too big. It was so big it overflowed. Alright. Is point something Java already has? Yeah, it's built into the, I forget what this stands for. It's a library built into Java. Standard library. Anyways, I guess we'll debug. Let's make sure the loop is giving us the right slopes first. Should be seeing a list of slopes. Okay. Let's See if we have a list of points in the slopes. Let's do this actually. Just output X and Y. Indent it. Okay. That looks okay to me. Let's output what the value from those are. Okay, let's output the tree count then. Tree count. Tree count is 31. Tree count is 71. Like, it looks like it's working, so I will assume that I'm not multiplying these right. Maybe, no. Maybe I can't hold these in an integer type. Maybe I need a long. Maybe it is actually that big. I don't think I have an error. I think this is just a really big number. Alright, let's try it. Woo, alright. Yay. Okay. Passport processing. You arrive at the airport only to realize that you grabbed your North Pole credentials instead of your passport. While these documents are extremely similar, North Pole credentials aren't issued by a country and therefore aren't actually valid documentation. Seems like you're not the only one having problems, though. A very long line has formed for the automatic passport scanners in the Lake Cup say your travel itinerary due to some questionable network security. You guys, you might be able to solve both of these problems at the same time. The automatic passport scanners are slow because they're trouble detecting which passports have all required fields. The expected fields are as follows: birth year, issue year, expiration year, height, hair color, eye color, passport ID, country ID. Passport data is validated in batch files. Each passport is represented as a sequence of key value pairs separated by spaces or new lines. Passports are separated by blank lines. Here's an example batch file. The first passport is valid. All 8 fields are present. Is that on the... Wait. Oh, separated by new lines. Oh, blank lines. There we go. Okay. Alright. Got it. The second passport is invalid. It's missing height. The third passport is interesting. The only missing field is CID, so it looks like data from North Pole credentials. Not a passport at all. Surely nobody would mind if you made the system temporarily ignore missing CID fields. Treat this passport as valid. Country ID? Oh, okay. Sure. Because North Pole is not a country. The fourth passport is missing 2 fields, CID and BYR. Missing CID is fine, but missing a field is not, so it's valid. According to the above rules, your improved system will report 2 valid passports, count the number of valid passports. Treat CID as optional. Alright. You know any resources to find stuff like that? Yes. This is something I do quite a bit. Here's code signal and leet code. Alright, so leet code and code signal. Both require sign-ins, but they don't really spam like my email that much, so I guess it's not like terrible. That not my password, really? Awkward. This one just logged me in. How nice. But yeah, they have this like this arcade, and they have problem that you can go through, just hundreds of problems, and then there's also challenges that people make up and stuff, and you can go and do them if you want. In any they support a lot of languages, so same with this. I don't know why. Maybe it's not an email. It said email though. Oh wait, maybe I used my GitHub. Let me try that actually. I bet you I used my GitHub. Yep, sure did. All right. But yeah, you can go to problems here, and you can choose some. You can see some are check marked. Usually I just start with the one that says easy, and then when you beat it, it gives you like similar problems you could try. So you can go to similar questions, and they're usually like harder, or they get harder. Those are both really good. Basically, you write the code, you submit it, and then it's like, oh, it passed all of our tests, you did it, or nope, try again. Yeah. Or you can participate in Advent of Code too. All the previous ones are posted on this site, just adventofcode.com. And next year they'll do it again, starting in December. I mean, I was planning to do it starting December 1st, and then here we are. Still haven't done any. But hey, I did 3 so far, so I'm making up for it. Do they get as real world like? Yeah, they do. Code Signal actually has what they call company questions, and I've attempted some of them. They're pretty deep. They're problems that like these companies like have to solve. And so I've attempted some of them, and they are pretty dang challenging. They're really hard though. Like before you get into these, you probably need to do some like medium to advanced ones. Actually, this one wasn't that bad, I don't think. Where'd my code go? It's been so long it got deleted. Rip. In Thumbtack, users are able to rate pros based on their experience working with them. The rating is an integer ranging from 1 to 5, and all ratings are averaged to produce a single number rating. Those pros who have a rating lower than a specified threshold are manually reviewed. You're given a list of ratings for some pros. Find out which pros should be manually reviewed. So yeah, that one's not too hard, but it's a thing. It's a real problem. Spam clusterization. This one was a pain in the butt. You're given a list of requests and IDs of the users who submitted job request descriptions. Implement the following algorithm to identify possible spammers. They had like a whole bunch of rules about this. Like you're given a list of requests, and then you're given a list of what do you call it? You're basically told to split it up into pieces, and then for each request there's like a threshold, and depending on how many like trigger words there are, it determines what the threshold is. It's kind of a pain. Anyways, there's a couple of those. They're really cool. Usually all the advanced ones are like real world. I think on Leak Code I did one that involved, what was it? I remember having to like read a string as an integer or like a decimal number or something, and you had to like convert it to words or something like that. That was interesting. And if it had like negatives or something, you had to put like negative, and if it had a decimal point, you had to like word it a certain way. It's just a bunch of like weird conditions. Yeah, this is Advent of Code. Oh wait. Alright, let's do some passport validating. It looks like it's just more text parsing, so sure, why not? I'm gonna copy the project this time instead of making a new one every time. AOC4, hey, it even knows. Count up by 1. Oh god. Java is my favorite programming language, so 99% of the time, if I can, I'll try to write something in Java. But if I can't, I'll try to write in C#, which is basically Microsoft's version of Java. And if I can't write in that, then throw any language at me, I'll do it. Except Python. Don't give me Python. I hate Python. I'll try to throw it out the window. I'll find any reason to use any other language before Python. Why do I hate Python? Because I hate the strict whitespace formatting. I hate how it handles like dictionaries and lists, and how it's kind of what makes JavaScript messy as well. Like you have these multi-type objects that you can then manipulate with all these I forget what they're called. They're like just like array manipulation methods or list manipulation methods. It gets so messy. And in Python it's encouraged, like, oh, make everything more compact by manipulating all your data with one like method instead of like writing out your code and make it verbose. Like I like writing raw code rather than I a lot of what Python offers is like a giant black box to me. And maybe it's cuz I didn't spend enough time like learning it, but I feel like I shouldn't have to put in work to understand like the basic data crap, running out of words. I shouldn't have to put in work to understand the basic data structure, um, to manipulate data structures. I shouldn't have to dig that deep, and Python makes you because it tries to put everything inside these like black boxes. I call them black boxes because I really don't think they are easy to understand. They're not intuitive at all. You 100% have to look up the docs to learn how they work. It's not like other programming languages where they're kind of giving you like raw structures and then you just manipulate the data inside those structures. It's not like that in Python. Python kind of hides it with a couple layers of abstraction. More so than other languages, in my opinion. Especially Python 3. It wasn't as bad in Python 2. But what I've seen in Python 3 looks bad. I don't like it. I will stay away from that language. I don't think my complaints are 100% valid because, like I said, I just don't work with it as much anymore. But that's just my personal preference. I prefer a language that I can code quick and easy in, and Java was one I picked up really quickly. Okay, enough rant. Delete this, and I'm just gonna leave that there because why not? Let's see. I feel like I will just put in what we're looking for here. Valid, or not valid, required fields. New string array. Boop. We'll do a couple of those. Boop, 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 boop. We're looking for BYRs and IYRs and EYRs and HGTs, HCLs, ECLs, and PIDs. Everything else doesn't matter. Okay. Java was your first, then C#. Well, that's good. Yeah, Java and C# are basically the same. Microsoft was just like, we gotta have our own language, guys. We gotta be special. Alright, so I will first... since there's a blank line between each of these pieces of data, we need to read... We need to continue checking for fields until we reach a blank line, which I assume has a length of 0, but I should probably double check that. So I'm just gonna do this real quick. loop through all these and see what the lengths are. Data I length. $31, what? What? Oh, you know what? I should probably save this into there, huh? There we go. It was 31 because it was this tree thing. Yeah, this is where 31's coming from. Alright, yep, new lines have a length of 0, so that's what we'll use. Okay. So while, we're gonna need like a counter or something. A line marker, or marker. While data line marker dot length is not equal to 0. We'll start parsing out fields, which should be separated by spaces. Yep. Yeah. None of the inputs have spaces in them from the looks of it. So I will do that. Data. Passport data. Data line marker dot split by spaces again. And after we do that, I don't think we need the line marker anymore, so I will increase it by 1 here. And then we will look at that passport data and split all of those by colons. So 4 I is less than passport data length. Take each one of those, passport data piece. And we actually just need the first part of it. We don't care about the second part. So data piece type passport data I dot split by colons, and get the first value. And finally, after that, see if, well, we need to make a checkbox for all these different required fields and see if they are all met for each one of these. So we'll make a Boolean array of required fields met. And we'll start them all as turned off. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. I could also do a hash map. Hash map sounds super convenient right now. I'm just gonna go with this. I already built this out. Why do some spaces look like new lines? Oh, these aren't spaces. These are new lines. The problem says that the passports can be multiple lines. It's just when there's a blank line, that's the end of the passport. So that's part of the challenge, actually, I assume. Anyway, passport data piece type. Check within our list of required fields. I need a new letter, J. Required fields, J++. If passport data piece type equals ignore case to required fields, J. Then change required fields met J to true. And then make sure int I is 0, I is less than required, fields met, length. Okay. Check through all the booleans. If any of them are false, what do we do with this? We're counting the number of valid passports. So we'll just leave the loop if this happens. We'll go, how would I go about this? Let's just say if all of them are true. We'll say all true is true. We'll set to false if any of them are turned to false. If all true, then that's a valid passport. Valid passports. Okay. If required fields met I. If not required fields met I, then all true is false, and we're done with the loop. We can just break out of it because we don't care about the others. If one's false, then it doesn't matter. And we can see how many valid passports there are now. We got 0. Alright, that doesn't sound right at all. Let's see. Let me make sure this part's working. This should be giving us the first letters before the colon. Data piece type. And it looks like it is. Oh, wait. I only did this one time. Well, that's kind of awkward. Okay. Now we have to do this for every passport. So, while, line marker is less than data.length. There we go. Okay. And we're stuck. Nice. Why are we stuck, though? Oh, I need to... Wait, I did advance the line marker here, though. And do I use it anywhere else? I don't think so. Nope. Interesting. So we advance the line marker. When it is, we move to the next one. Well, let me see what this is then. Line marker. Should say 0, 1, 2. So it got to here. Well, it did 0, 1, 2, and now it's stuck. Did all this. Oh, I have to advance line marker if we're out of here, I think. Otherwise, line marker just doesn't move. Because when the line marker's length is 0, it exits this, and then we have to advance. So there we go. I have to subtract 1, because that's not a valid index. Alright, so it says there's 21 valid passports. Alright, let's see. Boop. That is not the right answer. Okay. Interesting. Let me make sure these are all the fields. BYR, IYR, EYR, HGT, HCL, ECL, and PID. Uh-huh. Okay. Let's do this. Arrays deep to string. Required fields met. Dang it. A lot of falses, so something's not working here. EYR, which is the third one, is true. Then we have HGT, which was the fourth one, which is set to false. Okay. So something's not working here. We're checking passport data length. Oh. This check needs to be out here. When this is done, a whole passport has been read. So this is when we have to see if it's valid. So this needs to move out of here. Okay. So now there are 218 passports that are valid. That is still not the right answer. Your answer is too low. Okay. Let's see. Let's see if there's any hints here. 012, all true. I mean, that looks right to me. 4 and 5. All true? It said the answer was too low, so something that's supposed to be true is not true. Let me see. Lines 8. CID. That's whatever. IYR. Does it have BYR? No. I need to find... Okay, let me output... 28. It said IYR and PID was not included? Yeah. 155, 156. HGT? No HGT. Is there any condition I missed? Nope. Looks like I have the right conditions. Maybe I'm skipping a line. Okay, yeah, this looks... This might be... Let me see. I think I'm skipping a line. I'm noticing that, actually. Wait, no. I think that's supposed to happen, because... Line 295, which should be 296, should be a blank line. Yeah. Okay, that's supposed to happen. So add to the line marker. That's for this while loop. Yeah. That's fine. That doesn't hurt anything. Very interesting. Did we get all the data? Oh. Nope. I am missing the last line. That must be why. Let me think. Okay, yeah, because the logic's kind of messed up here. It goes, add a new line. Boom. Now we're back up here. Line marker is increased by... Okay, yeah. That's annoying. I bet you this one's valid and I just have to add one to it. If I wanted to fix it, I would have to add a special condition. But I bet you it's just 1 plus whatever this is right here, because that looks valid to me. So let me try 219. That's the right answer. Yay. All right. I mean, if I really wanted to fix this, then I would add a condition. What about text editors? You mean like IDEs? Like for Java, I use Eclipse. For most languages, I use Notepad++. Like, not even joking. A lot of people use Visual Studio Code nowadays. That's a pretty good one. I will admit, Visual Studio Code is pretty good. I usually use Notepad++. Because I'm kind of like old school. Notepad++ doesn't pop up with like any fancy like you might have noticed when I was coding all of these, I kind of already knew like what to type. I didn't really have to like look up anything. Like I just kind of get familiar with the language and then I don't have to bother with any fancy IDEs. So I'm totally fine with using Notepad++ and then running a compiler over and over. But the nice thing about an IDE, like the best part is you can like hit a run button and everything compiles for you automatically. But yeah, I usually just stick with Eclipse or Notepad++. I guess if I were to do C#, I would get Visual Studio. Again, a lot of people do Visual Studio Code nowadays, which is like I guess a more modern version. Alright, what do you want? The line is moving more quickly now, but you overhear airport security talking about how passports with invalid data are getting through. Better add some data validation quick. You can continue to ignore the CID field, but each other field has strict rules about what values are valid. Oh no, input validation. Birth year has to be 4 digits, at least 1920 and at most 2002. The issued year has to be 2010 and 2022. Expiration year, at least 2020 and at most 2030. A number followed by either CM or IN. The number must be at least 150 and at most 193. Okay. It's just a bunch of like little checks. So that part, the other piece I now have to include. Passport data piece. I actually need the other side of this data now. Alright. Well, it's okay. Take it one step at a time. It looks like that's all we're doing, though. Data validation. Count the number of valid passports. Those that have all required fields and valid values. Alright. As for the last line, if I want to fix it really quick, I would just... Boop. There we go. I added a new line to the bottom of my file. That way my thing won't be dumb about it. Let me actually rerun this real quick. It should say 219 now. Nope. Let me add a line that says A. I think it needs a line of text. 219. Okay. I just wanted to make sure that was fixed. I can fix it through here, but I really don't want to add a random condition at the bottom just to fix that right now. It's an edge case. If I'm trying to program quick, I don't really care about the edge cases that much. We're not going for perfection, we're going for speed right now. Speed. Birth year. Alright. So depending on the type, there is a certain condition. So I think we're gonna do a switch statement. Lovely. How about we do that in here, actually? That way we know it's a proper field, first of all. Alright, so switch the passport data piece type. Case. We have BYR. And we're going to do each of these. IYR, EYR, HGT, HCL, ECL, and PID. Okay. Alright. This is going to be our validation. So, we're not going to say required fields met, J is true. Well, I guess we could put as the default case. If it's anything else, sure, why not? So for the birth year, it has to be 1920 at most 2002. So we'll do a integer conversion. Year. Pass integer parse int. Passport data piece. Oh. And then it needs to be at least 1920 and at most 2002. So say required fields met J is equal to year is greater than or equal to 1920 and year is less than or equal to 2002. Alright, and then for the issue year, it needs to be 2010 to 2020. 2010 to 2020. Alright, next is the expiration year. Which can be 2020 to 2030. Alright, height. It's gonna be... Alright, let me think about this for a second. We'll see if CM and IN is in there first. Passport data piece contains IN. Or CM. And if it does, we're gonna read in the numbers. So I believe, I guess we could test this real quick. If I just do a straight up conversion on a string, integer parse int conversion on a string with the numbers in it, I bet you'll only return the numbers portion. Nope, it doesn't. Alright. Fair enough. We're gonna have to strip out the letters then. Alright. Place IN with nothing. And replace CM with nothing. That's our new string. So, and then we'll convert it. So, number. Parse int that. Alright, now that we have our number, depending on if it's CM or IN, why do I... I'm not going to do a switch for that. That's kind of ridiculous. Else, it's going to be CM. Don't do that. So this will be true if the number is greater than or equal to 150. Oh wait, that's inches. 59, and at most 76. And number is less than or equal to 76. Number. And then this one. 150. 193. Alright, next. Hair color is a number, a hashtag, or a number. HCL. Reason HCL. What? Z? Well, that's definitely gonna be wrong. A number followed by exactly 6 characters, 0 through 9 or 8 through F. 1, 2, 3, 4, 5, 6. What? A pound sign. Oh, here we go. A pound sign. Okay. Like this one. Oh, cool. So it's stored like a hex color. All right. Well, look for a hash first. Kind of do the same deal here. There's a hash. We will go into that. I guess if any of this is not true, we just don't do anything. Yeah, that's fine. Yeah, we just don't say the required field met is true or false, because it's already false. Okay. Then we have hexadecimal letters. Okay, that's easy enough. For int I is 1, because we're not going to... The 0th character, the first character is hashtag. I is less than passport data piece dot. Well, let's see if the length is correct. First of all, it needs to be 6 more characters after that. And passport data piece dot length is equal to 7. Alright, then we continue. If passport data piece character at I is less than 0, or let's do this. Boolean all valid is true. If all valid, and we'll just do this. Required fields met j equals all valid. We'll set all valid to false. If any condition pops up that's not right, or it's greater than 9, and passport date. Wait, no, that's not going to work. It's going to be one of these two conditions has to be true. For this to work. So it's just more ors. Wait, no. No. Hold on. How about we see if it's... It's a lot easier to write the truth logic, so we'll just put a not in it. So if the character is between these ranges, or... So this needs to be an and now, or it's between these ranges, A through F. I. And then we're going to put a not around all that, which will negate that logic. And I'm already using I, aren't I? Yep, let's use K. K. Alright. So put a not around all that. Then all valid is false and we'll break. Cool. And then we have eye color. It needs to be one of these. One of those. Alright. I'm gonna do a static string eye colors. String array valid eye colors. Boop, 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 boop. Up here you go. Wait, no. We're in a stack function, that's why. Alright. Well, we'll do that then. Valid eye colors. I'm just gonna copy this. Boop. Replace space with this, comma this. In selection. It doesn't have in selection. Gosh. Stupid Eclipse. Why you be dumb? Space, comma, in selection. There we go. More or less. Whoa, don't be retarded. Alright. That was harder than it should have been. Alrighty. Back down here. Or, wait. Yeah. It's just gonna be one of these colors, right? Or int I is 0, I is less than. Boolean matches is... Well, if it matches, we're good. We'll just set it to valid then. Part fields met is true. Split screen, yep. Well, not split screening, but the IDE allows you to break it up. So yeah, a lot of times when I start doing, when I start having to look at other documents, I'll start doing stuff like this, and then I'll start splitting the screens in various ways, and then I'll be at multiple points in multiple files, and it's great. It's lovely. Now I might put another one, you know, that sort of deal. And then I need to minimize that because that's too big. It's great. It's another nice thing about IDs, right? Alright, let's not... Or sometimes I need... It's kind of rare, but sometimes I need to split it the other way. So sometimes we'll go like this instead. If it's like a very... Usually I don't do this one, though. If I had to do something weird like that, I guess. I don't know. That's a little more confusing, in my opinion. Most of the time. Fun. Yeah, because this is at the top of the document, and I don't want to have to scroll back and forth, so. When you have like 1,000-line files, comes in real handy. Oh yeah, we can't use I, we have to use K. K is less than valid eye colors. Alright, if what was it called? Passport data piece. That is not right. Passport data piece. Character contain, not even contains, needs to be equal equals valid I colors K. Required fields met, and we can break because we're good there. Alright, next. Passport ID needs to be a 9-digit number, including leading zeros. I mean, then it's just a 9-digit number, right? Yeah, that's pretty much it. We'll just loop through all of the characters and see what we got. It's Boolean all valid is true. Required fields met, J will be equal to all valid. If passport data piece character at K is greater than or equal to 0 and less than or equal to 9, then we're good. Or if it's not within this range, I'm just gonna do the inverse logic thing again. We'll say all valid is false and break out of this loop. Cool. Alright, I think we have all of our data validation done. So I'll just run it and see what happens. It says 129 passports are valid. Well, time for the moment of truth. That is not the right answer. Your answer is too high. Welp. It's gonna be very hard to figure out what is wrong with our data validation. But I guess we're just assuming that all the code I wrote is doing what it's supposed to do, so maybe I should review that real quick. I can test it in individual pieces just by throwing them in a function real quick. Let me do this. I didn't really write this for testing. Here, let's do this. Public static void boolean is valid height. Given an input, return if it's a valid height. Okay. So yeah, we can just do a quick check here. Probably do this for all of them. Make sure they're okay at least. Is valid height. So let's try things like 153 centimeters. That should be valid. We'll do 80 inches should be invalid. And 71 inches should be valid. So it should be true, false, true. True, false, true. Okay, that looks alright. Let's try eye colors. That one seems pretty trivial. I don't feel like that would be an issue. Yeah, that one seems pretty trivial to me. I don't think that one would be broken. Passport ID. Oh wait. This has a character limit. I don't think we checked that. We just checked if all the numbers were valid. It needs to be a 9-digit number. Alright, if passport data piece length is equal to 9. It needs to be. So I didn't do a length check there. That might be the issue. It says there are 127 valid. How many did I put before? That sounds like the same number to me. Maybe it was 129. Aha! Yes! That was the problem. Woo! Alright. I'm not quite there yet, but we're getting close to mental fatigue point. So we'll go one more. One more. You board your plane only to discover a new problem. You dropped your boarding pass. Great. What an idiot. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people that suddenly made it through passport control. You write a quick program to use your phone's camera to scan all of the nearby boarding passes. Perhaps you can find your seat through process of elimination. Yeah, speedrun until midnight. I mean, traditionally, you have until Christmas, so yeah. Instead of zones or groups, the airline uses binary space partitioning to seat people. A seat might be specified like FB, FBB, FFRLR, where F means front, B means back, L means left, and R means right. The first 7 characters will either be F or B. These specify exactly one of the 128 rows on the plane. Each letter tells you which half of a region the given seat is in. Start with the whole list of rows. The first letter indicates whether the seat is in the front or the back. The next letter indicates which half of that region the seat is in, and so on, until you're left with exactly one row. Wow, that's kind of impressive, actually. For example, consider the first 7 characters of FB, FBB, FFRLR. Start by considering the whole range, rows 0 through 127. F means to take the lower half of that range, so we're taking 0 through 63. Then we have a B, which is the upper half, so we get 32 through 63, okay? Then we take the lower half of that, which is 32 through 47, then 40 through 47. B keeps 44 through 47, 44 through 45. The final half keeps the lower of the two for row 44. The last 3 columns will be either L or R. Those specify exactly one of the 8 columns of seats on the plane. The same process is used, this time with only 3 steps. L means keeps the lower half, while R means keeps the other half. Alright, so we're basically doing, like a binary search algorithm, except the search involves us just, calculating our seat position. Every seat also has a unique seat ID. Multiply the row by 8, then add the column. Here are some other boarding passes. As a sanity check, look through your list of boarding passes. What is the highest seat ID on a boarding pass? So they want the highest seat ID of these boarding passes. Alright. Let me make a thing. I was hoping to do actual binary, but this is more of just like this is more just like a binary sort type of deal, kind of. It's the binary cutting part of the sort. I'm gonna save this over that. AOC 5. And refactor this. And delete all this. Alright. And this, why did this not, wait. Oh, this is AOC 4. Oops. Go back. Alright. I did not mean to touch that. AOC 5. Oh. Select, please. Hello? Alright. Okay. Whew. Alright, so start with the loop. You have to read in everything, so. Firstly, we're gonna take only 7 characters, because the last 3 are not needed for the first portion. So I will cut it up into 2 strings. One to indicate the row code, data.substring, data I substring, not sequence, substring. From 0 to, I believe, 7. I think it's exclusive. The substring begin index extends the character at index end index -1. That sounds like what we need. Yeah. So that's the row code, and then we have the seat code, which should be the rest of it. From 7 onwards. So I can just say 7 here, I think. Let's validate that that's working. Comma. Seat code. Yep. Okay. Now. So F means the lower half and B means the upper half. F is lower half, B is upper half. Okay. So basically we'll keep 2 ranges of seats. Seat lower bound and seat upper bound. I should put 127 there. So we're going to go through the row code. And see what it is. Character at J. If it's an F, then we're gonna bring C to use value. We're gonna cut seat use value in half. And if it's seat, and if it's a B, we're gonna take half of the length of this and add it to seat L. So when we take the upper half, we're adjusting the bottom value. So if this was 64, a space of 64, we add 32. And then for lower half, we always modify the upper value, where it was 63 before. We take half of the space between here and here, so 64 minus 32 is 32, divided by 2 is 16, and we subtract that. So C to U use value will be equal to seat U minus seat L divided by 2. Order of operations. So that would be a 120. Well, I need to add 1 to these, I think. No? Wait. Yeah, I have to add 1 to something. Probably the upper bound. Plus 1. I think subtraction is non-associative, so I have to do this. But yeah, that should be fine. And then, so as an example, if seat L was 32 here, then it would be 128 minus 32, which is like 96. And then you take that divided by 2, which is 48, and that's how many seats you subtract. I guess I'm doing a minus equals here. We subtract that amount. Otherwise, we're doing the lower half part. So seat L goes up by whatever this I think it's the same calculation. Yeah, it should be the exact same calculation. It's just whether we go up or down. And which one we go up and down with. So what I can do is after each step, we can output what the new seat L and seat U values are. Add a tab. All right. All right, so we can take a quick, where'd my other output go? Oops. I kind of want that so I can compare. All right. So F was 063, and then again, so 031, then here's 1631, 1623, 2023, 2021, and then eventually we converge. Is that right? That looks right to me. But let me confirm this by seeing what this gives me. I'm just going to inject that into the top here. Compare it with the example they gave us. It should be 70. Yep, that's what we got. So that pretty much confirms that it's working. Now we do the same, but for the row. So for the row, or not the row, the column, we have R means right, L means left. Oh. Wait, what does that mean for, does right mean increase? R means upper. Okay, yeah. R is upper half, L is lower half. That's an L, if you believe. Okay, so int column L, or just use like similar variables basically. Column U will be 8 max. Alright, pretty much the same deal. Except we're not using the row code now, we are using the seat code. And we're not using Fs, we're using Rs. R is for upper half, so I want L here, because that's subtracting this for the lower half. And we're not using seats anymore, we're using columns. Seat U, column U, seat L, column L. Okay. And we can do this. See what that looks like. I don't think that's supposed to be an 8. It's supposed to be a 7. Because I already add the 1. There we go. Now it converges properly. So this should have been column 7. Which, yep. So now, the seat ID, which is taking the, multiply the row by 8 and add the column. And for the problem, we need the highest seat ID. The highest seat ID. Int highest will be 0 at first. So we'll calculate the seat ID. Will be equal to the row. So I can use either value now. Seat L or seat U should be the converged value of what the row is. Multiply that by 8. add the column. Again, I can use either value. If seat ID is greater than highest, it becomes the new highest. Repeat until all passes are done, and output the highest pass. Alright, so according to this, the highest is 904. That's the right answer. Alright, part 2. Ding! The fasten seatbelt signs have turned on. Time to find your seat. It's a completely full flight, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 and -1 from yours will be in your list. What is the ID of your seat? What? Oh, your seat. So your seat should be the only missing boarding pass in your list. So if I went through this. Wait. So I have to make a compilation of all the seats? Your seat is not at the front. The seats with IDs +1 and -1 from yours will be in your list. So basically, all these boarding passes that we have are all the other seats except for ours. I don't understand this part, though. Some of the seats at the very front and back of the plane don't exist on this aircraft. So they are also missing from your list. I guess what I should do is make like some kind of visual of what the seats look like so I can figure out what's going on. Because right now I can't tell. So we're gonna make a grid of seats using all these. Alright. I'm gonna have to store coordinate data. Let's do a list of points. Seats. Seat data. New array list. Point. Alright. Boop. Boop. Okay. So I am going, after we figure out what the column and seat is, we're going to record that into seat data. Seat data dot add new point seat L, comma, column L. And then once we have all of our seat data, we're going to make it, output it and make it look pretty, or try to. I think the easiest way, since we know how many columns there are, I guess we kind of know how many rows and columns there are. We'll just make a giant grid of X's and then we'll make them O's when they are occupied. So first I'll I guess I'll make a string array for this. String array of seats. Seat display. I'm gonna say 128 rows. 128 rows of that. So we're gonna say, I guess I'll initialize it first. I is less than seat display length. Seat display I will be equal to xxxx. 8 of those. That means they're unoccupied. Maybe I should use like, let's make it a little more. 1, 2, 3, 4, 5, 6, 7, 8. I use dashes because it'll be a lot more obvious. Alright. So now that we have our seat display, I am going to take all the seat data for point P in seat data, and we're going to modify seat display to include that. Seat display p.y. The column, wait, is y the column? Oh. Y is the column. So seat display x is the row. Equals, well, let's actually take our yeah, that's fine actually. Seat display p.x, and we're going to, oh, let me think. We need the substring from 0 to whatever p.y is, plus the plus I guess an O or something. Yeah, we're gonna use an O. And then the rest. Substring p.y onward. Because p.y is going to contain the position that it belongs in. 0, 1, 2, 3, 4, 5, 6, or 7. So if it's, for example, 0, the substring from 0 to 0 is nothing. And the substring from 0 onwards, I guess this would be a +1. Because that spot will be occupied by this letter. And that'll be the new seat display value. And then finally, we need to output this array. So I will do a nice loop here. And we'll just display each one on a separate line. We'll see what it looks like. Oh. So I'm assuming there was some of the seats at the front and back of the plane don't exist, so they'll be missing from your list. So I assume these are the blank seats that they're talking about. Now there's one here that's not occupied. And the seats with IDs +1 and -1 from yours will be in your list. So it must be this. So I guess what the algorithm would be is you for all the seats before this, they are not included. And for all the seats from the front till a certain point, they will also not be included. So the algorithm wanted us to find this right here. I'm pretty sure. Now, since we already mapped out the diagram, we kind of already know where it is, so we can calculate the ID of our seat manually now. I don't... Could write the program for it, but it's like, at this point, we wrote a program to just display them visually, so might as well just calculate it at this point. This is row 84, which is going to be which is really going to be 83 internally multiplied by 8 plus our column 1, 2, 3, 4, 5, 6, which is column 5 internally, which gives us a seed ID of 669. That's the right answer! Yay! We did it. We found our spawn the plane. Power programming. Alright. Very good, very good. These are pretty fun. I assume D for DJ is probably working again, so I'm gonna try one more time. Play a little bit of that, and then probably sleep once I feel tired.